Welcome everyone to our sixth episode of this series, Datadog On. This is a series that we are building at Datadog to basically we invite engineers who are working on Datadog itself every day to share their experience about a particular technology or a particular problem that they're solving from an engineering point of view. This is a super exciting episode that we have because we are starting KubeCon week, the Kubernetes conference, and we took the opportunity to do a follow-up session that the first one that we did, which was Datadog on Kubernetes. The idea of that first session was to explain a little bit how we have built our Kubernetes clusters at Datadog. And this second session is a follow-up of people who were asking questions about how we monitor Kubernetes itself. So the goal of this one is that topic. Hopefully, by the end of the hour today, you will have new ideas that you can apply to your own clusters to better monitor them. So some housekeeping items. So the idea here is that we are going to try to leave enough time at the very end for questions, but you don't have to wait at the end to ask them. So you have a Q&A button in your Zoom client, and you can leave there your question throughout all the webinar as soon as you think about something that you want a follow-up on. And at the end of the session, we will go through those and try to answer all of them. Okay, so this is obviously a talk about how we monitor Kubernetes at Datadog, our own cluster. And obviously what we use for that is Datadog itself. So Datadog is a monitoring and analytics platform that helps companies improve observability of their infrastructure and applications, including of course, Kubernetes and the applications that you run on top of Kubernetes. My name is Ara Bolide. I'm a technical evangelist at Datadog. That's my mail and my Twitter handler. I run these Datadog on sessions. So if you have any topics, any feedback, anything that you want us to cover, please reach out and we will try to organize a session about the topics that you're mostly interested in. But obviously I'm not the important person here today. I'm joined today by Celine and Charlie, who are both software engineers at our container integrations teams. Celine, do you want to introduce yourself?
Yeah, hi everyone. I'm Celine. I'm a software engineer on the container integrations team. I've been on the team for a little over a year now, and I've really enjoyed learning more about Kubernetes and Docker and how we can improve monitoring in this space. Before joining this team, I worked on the Watchdog product at Datadog, and prior to that on monitors.
Cool. Charlie?
Hi, everyone. So on my end, I've been in the container integration team for a little over 3 years now, and I've been leading the two of the projects we're going to talk about today, the cluster agents and the watermark for autoscaler. Personally, I'm really interested in the aspect of autoscaling and scheduling components or workloads, and really discovering, making sure we have SLO, SLAs, etc.
Fantastic. So Celine and Charlie are part of the team who basically manage Datadog agents to monitor Kubernetes in our cluster. So obviously they're going to be great to hear from. So I think it's important also to introduce a little bit the scale that Datadog runs on. Some of the decisions that we make in our engineering process are related to our scale. So I think it's important to just give a little bit of introduction. Datadog currently has more than 12,000 customers. We are a monitoring company, so we get data from those customers' hosts that sum up to millions of hosts. And we process trillions of data points per day. And in terms of our Kubernetes infrastructure, we have dozens of clusters running, some of them with thousands of nodes per cluster, and we run them on several clouds. So pretty big Kubernetes that we run, and also with the challenge on top of doing on several clouds. But why we decided to run on Kubernetes? So Datadog wasn't running on Kubernetes before. This is a new infrastructure that we started several years ago. And there were many reasons why we did this. The first one was we wanted to move to immutable infrastructure. We selected Kubernetes because of its large community. Also, obviously, it helps us with our multi-cloud strategy because it adds an abstraction on top of the cloud. But one business reason that was very important is that we wanted Datadog to be the best monitoring solution for people running their workloads in Kubernetes and to monitor Kubernetes itself as well. So obviously, the best way to make sure that that happens is if we run Kubernetes on our own production clusters. So that was several of the reasons why we picked Kubernetes for our own infrastructure. Cool. So let's go into the topic today, which is how we monitor Kubernetes. But before we tell how we do it, let's give a little bit one-on-one on what we need to monitor when we have a Kubernetes cluster. Celine, do you want to give us a little bit of overview?
Yeah, sure. So as you may be aware, in Kubernetes, there is a control plane, and these control plane nodes act as the central nervous system of a cluster. And the API server can be considered as the brain, ensuring that the desired state of the cluster is maintained. And along with the API server, we have the etcd, a scheduler, and controller managers, each of which have their own important and unique roles. And it's important to know that each of these are performing their roles as expected and are healthy. So in addition to monitoring the control plane, we also want to monitor the worker nodes that are actually running the applications of interest for the business. And on these worker nodes are the kubelet, which is interacting with the API server and making sure that the nodes themselves are running the pods that they need to be, the container runtime interface, as well as the container runtime, and of course, the workloads, the application pods themselves. And so having a complete idea of how the health of all of these is important to make sure that your Kubernetes cluster is healthy. And so we can get data from these components in a few different ways. Kubernetes provides two services as add-ons, the metrics server and kubestate metrics. The metrics server provides aggregated resource data that's provided by the kubelet. And kubestate metrics provides more detailed information about your resources available from the API server, such as your pods, your nodes, your deployments, and so on. For instance, how many are running, what their status is, how many times they've restarted, what their resource limits are, and so on. And we can also leverage metadata that are available via the kubelet to configure auto discovery of integrations that you may be running on your nodes. And I'll discuss that in a little more detail in a couple of slides. At the core of monitoring Datadog is the node agent. And the node agent collects data available on the individual nodes and forwards them to Datadog servers, including the data that provided via integrations with metrics server and KSM. It can be deployed in a few different ways, but we recommend deploying it as a daemon set to have complete monitoring across your whole infrastructure. And the agent, it talks to the API server to get cluster level metadata that can then be associated with your metrics and your logs and your traces that are submitted to Datadog. And the agent also communicates with the kubelet to get a pod list and in general pod lifecycle events and their associated metadata. And these metadata are used to know when a new pod service can be associated with an auto discovery configuration that you have set up. So auto discovery is a key feature with the agent in Datadog in Kubernetes because of the dynamic nature of pods. Pods can quickly be removed and added, and often they can run on any of a number of nodes. So identifiers like host names or IP addresses can be in flux. So the way auto discovery works is that the agent, you have a configuration set up via the agent, either as a file, as a YAML file, or as an annotation in your Kubernetes pod. And then we match that configuration with a service that's running via an auto discovery identifier. And here's a snippet of a Redis pod manifest that's configured to use auto discovery. And you can see that right in the annotations, we have configured the check name and the instances. And this configuration is matched to a container running on this pod called Redis. So it'll find any container that has this name, and then it'll template it and then start collecting your Redis metrics. As I mentioned earlier, you can also have this configuration set up in a file based on the image name. So it'll use the short image name as the identifier and match that image to any containers that are running. And we also support custom identifiers via Docker labels.
Very cool. But it's the node agent that you explained is not the only Datadog agent that you can deploy on your Kubernetes cluster. As soon as you start growing, a second one becomes more and more important, which is the cluster agent. What is the cluster agent, Charlie?
Yeah, so as you pointed out, because the node agent, or rather, if you want to collect cluster level metadata that's not available on the node itself, you will quickly hit a bottleneck if you have all of your agents query the API server. And so a few years back, we introduced a new component that we called the cluster agent, Datadog cluster agent. And its first role was to provide the cluster level metadata to all the agents as a proxy, essentially. But then we discovered that we could leverage it to have a separation of concerns so that the cluster agent would pertain to the cluster level orchestration. And that enabled us to introduce two really key components and features in the cluster agent. Namely, we first implemented the external metrics provider, which is an API that you can register in Kubernetes to provide metrics for the horizontal pod autoscaler. And so essentially what we enabled our users to do was to use metrics from their Datadog account to scale their workloads in cluster. And then the second feature that we introduced, we called it the cluster level checks. And the cluster level checks is a smart way to schedule heavy workloads in terms of processing. As Celine mentioned, the kube state metrics component will give you a state of your cluster and all of the different elements, whereas it's deployment services, pods, etc. And as your cluster grows, the output of this component can be really, really big. And for a single node agent that has the same resources as all of its peers from the daemon set, it could quickly get into an out-of-memory state. And so with the cluster level checks, we were able to design a pattern where the cluster agent would split the workload and schedule the checks for different workers, or different node agents. But this also enables us to monitor elements that are outside of the cluster, namely, if you have a relational database in AWS, RDS, or in Google, or in Azure, you will be able to use a cluster check to monitor it because it wouldn't be able to auto-discover it otherwise.
Cool. Yeah, very important topic, the cluster agent. So let's start by talking about how we do things at Datadog after this introduction on Kubernetes 101 monitoring. So the first thing that we said is that we recommend to deploy the node agent as a daemon set. But is it, do we actually deploy it exactly as a daemon set, Celine, internally?
So initially we did start out deploying it as a daemon set, but we started to face issues and limitations with the daemon set when rolling out on large clusters. For instance, we couldn't control the rollout speed, which led to issues of overloading the control plane. We couldn't test a new version of the agent on a subset of a large cluster, which isn't the same thing as testing on a small cluster. And we couldn't deploy a different configuration on a specific node group that had different resource needs because what was running on them. And these limitations became critical to us and led to the development of a new controller called the extended daemon set. And the extended daemon set is open source and available to everybody. Its key features are that there's a custom rolling update where you can configure how many pods to update simultaneously and how quickly. There is a canary deployment, which allows you to test a new agent version on a relatively small number of nodes and then validate it before continuing. And there's also the extended daemon set setting, which is a custom resource definition that allows us to have a different resource configuration for a particular node group. And here's an example of the extended daemon set controller, a manifest for it. You can see here under strategy, there's a configuration for the rolling update where you can set the max number of pods that can be unavailable at a given time, the max number of pods that can be created in parallel, and how fast the rollout should be, the interval. Under canary configuration, you can set how many pods should participate in the canary and the duration of that canary, after which it gets automatically validated and then the complete rollout starts. And you can also use an auto pause feature. And with this feature enabled, what it does is you configure a max number of restarts that's tolerable. And then if one of your pods restarts more than this max restarts, then the canary duration ticker pauses. And this gives you a chance to inspect the canary pods and decide whether it's an issue that's fleeting, after which you can just continue the deployment as planned, or if it's a real issue, in which case you can fail the canary and it'll restore the currently active daemon set on your cluster. And the extended daemon set is very useful for these reasons, but it is yet another controller that you would have to deploy. And we're currently in beta for something called the Datadog operator, which will unify deployments for everything that you need in Kubernetes, just using a single configuration file. So stay tuned for that.
Great. So just to tell everybody, the extended daemon set is open source on the GitHub org. So once we publish this video, the recording, we are going to make sure that we add those links to the description. But again, you can search for it on our GitHub org. Fantastic. So now platform monitoring. So when you on Kubernetes, we have what we normally say control plane nodes versus worker nodes. And something that happens is that some people run Kubernetes in a managed infrastructure, like managed Kubernetes as a service that some clouds provide, like GKE or AKS, depending on the cloud or EKS, depending on the cloud that you're running on. Or you can, and those services, what they do is that the cloud itself is going to help you run your Kubernetes infrastructure by running the control plane for you. At Datadog, we don't use any of the services. We run our own control plane, and that's why we need to make sure that we have clear monitoring strategies for the platform itself, for Kubernetes. So Charlie, do you want to introduce us what that means?
Yeah, absolutely. I did see a question with regards to monitoring the hosted and monitoring the EKS or other services for Kubernetes. So what I'd like to talk about right now is, yeah, very specific to if you're running your own control plane. However, we have a lot of experience with monitoring GKE, EKS, and all the others. And I'd love to dwell into that after. But with regards to the self-hosted control plane, well, first of all, I like to think of Kubernetes as a well-crafted symbiosis of independent controllers. And in a very abstracted way, as Celine pointed out earlier, we have this stateful element, the storage called etcd, and we have the stateless main controller, the API server. And its role is to go and compare the desired state, which is stored in etcd, with the current one that it witnesses in the cluster. And it tries to reconcile both of them. And so if something needs to be done, say a replica needs to be scheduled, a pod needs to be created, then the API server will defer to another controller to find where the replica can go. This controller is the scheduler. And once the scheduler has done its algorithm, its work, it will defer to another bit of software, the kubelet that is running on every node, and especially the node that we want to schedule the workload on right now. And then the kubelet will do a bunch of work, will create a sandbox, and it will defer the rest of the work to the container runtime to actually spin up the container. So what this means from a monitoring standpoint is we need to ensure that the controller is healthy, but we also need to ensure that the controllers can communicate among each other. And all of the controllers that we're going to talk about expose a set of metrics that follow the open metrics standard. And the Datadog agent is able to process this endpoint and generate Datadog metrics from a simple parsing pass of this endpoint. But it can also enhance the metrics by combining them with other metrics or adding insight from the cluster agents, the kubelet. So all of the metadata that we've mentioned earlier, these can be leveraged. Now, more specifically, the main one, so the brain, the API server. So this is the bit that will reconcile everything cluster-wide. One note is every controller in Kubernetes has the reconciler loop. So this is something we're going to talk about, but for the API server specifically, what you want to look at is how many objects are there currently in the loop? How many things are being reconciled? What's the error rate? You might know that, but there are two ways to communicate with the API server. You can use kubectl or kubectl, or there are many ways to say this tool. We actually have a video on this one that's really, really nice. But you also have the client, which is embedded in your code. If you want to make calls to the API server to create, delete, update, etc. resources. And what this means is you need to pay attention to how many calls are being made, how many transactions, client-server transactions there are, what's their duration, what's the type of calls. And so the reason I'm putting a strong emphasis on the client-server transactions is because one of my favorite patterns available in Kubernetes is called the informer pattern. To put it simply, every object has a resource version, and you can inquire to be notified when a change occurs on an object. So the client makes an initial list call to get all of the resources that correspond to a filter that you set, and then it watches from that point forward. It will receive the events from the API server on additions, updates, deletions, and then you can take actions on those. And that's the controller part of the informer. But what this really means for us is you need to monitor how loaded the server is, the API server is, how many clients are watching, and how often they're getting resources. In very large clusters, a single list that is not properly scoped can take dozens of seconds. So you wouldn't want to have a bloated server because too many clients are trying to reach the same data too often. And then we have etcd, the stateful bit of the masterpiece. Obviously, you should run it in HA, high availability, but this means you need to monitor the leadership status. etcd, you might know that, but it uses the Raft consensus, one of my favorite algorithms in the distributed system worlds. etcd is its own CA, certificate authority. And so it is obvious that you need to monitor and configure the clients that are talking with it. You need to make sure they use proper authentication, authorization, and to this extent, because it's its own CA, you need to make sure you monitor the certificate sets used by etcd. And then if you run it in high availability, you need to make sure that the nodes where you run etcd can accommodate the replicas. My personal recommendation is checking the disks you use to store the data. Paying a little extra to have faster disks can often save you a lot of trouble down the road. And without getting too deep into the chaos world, you need to make sure that your etcd setup supports a leader shutdown. You need to know how long it takes for a follower to assume leadership, and you need to monitor this bit too. The next controller I want to talk about is the controller manager, at the helm of controllers. It is often overlooked because you don't often customize it, but I like to use it as a general example of what to monitor when you have a controller, a custom one. The upstream library for all of the tool sets that are available upstream will embed ways to export metrics. And so what you will want to care about is the processing time for every item in the queue. And so as it depiles an element, processes it, you want to make sure if it's gone through, how long it's taking, and because they expose, the metrics endpoint exposes distributions, you can make sure that for the P99, for instance, it's running smoothly. And another under-leveraged feature of informers, in my opinion, is the cache. So instead of hitting the API server, when you run your informer, you can internally store the state of the data that you're looking at and watching. And so then you can, instead of hitting the API server, you can query your local cache to relieve the pressure on the API server. Now, finally, my favorite bit personally is the scheduler, especially because you can make your own custom scheduler. And so you can just specify in the deployment spec of your deployment or daemon set to have which scheduler it's going to use. And I think it's important to monitor the actual lifecycle. So you need to extend your monitors beyond the controller loop to how many pods are pending, which mean how many items does the scheduler have to work with? Why are they pending? Is it a matter of toleration, sizing issues with the requests you've put and what's available for CPU memory? And if you can, make sure that you have an eye on how long it takes for a scheduling request to get in and up to the container to be created. Think of the API server request, the algorithm of the scheduler, request to the kubelet, creation of the sandbox, image pool, container start, etc.
Cool. Yeah, so making sure that you understand how many of those pods are pending and why, I think it's critical to make sure your developers understand what's going on with their workloads. Great. So another bit that is important to track from the API server are audit logs. What are those, Charlie?
Right. So audit logs, I think, are one of the most powerful tool to have insight into the orchestrator. And I'm saying that with a very biased opinion of being passionate with monitoring. But the API server gives you a tool set that basically, as it outputs, it can output everything it's doing. An operator or a user can specify a policy and it can configure what they care about. So you can store them and rebuild a cluster entirely, rewinding the log file if you wanted to. And that's how beautiful it is. But you can do some forensic as well to know why a certain service was deleted, or a deployment was scaled down that caused an outage, which oftentimes is helpful. So indeed, without going too much into details, the audit logs will get you a really nicely formatted JSON file that will tell you who did what, when, and how. And then you can set up your monitoring in place to make sure that the rate of action is correct, the rate of deletion is also respected, etc.
Cool. I think it's very cool to see how Kubernetes is a very modern infrastructure framework, because they have all these nice embedded tools already to make sure that monitoring is a lot easier.
Right. Yeah.
Cool. Now we have an idea on how to monitor the control plane. How about the workloads? The applications that we're running, obviously we don't have Kubernetes for the sake of it. We have it to run our applications on top. So how we are monitoring, how we are going to monitor those apps, Celine?
Sure. And at the basic level, one of the most important things to keep track of is whether your pods are running and healthy. And this can be challenging to follow and manage manually as your cluster gets very large. And luckily, Kubernetes provides liveness and readiness probes to help automate simple actions based on the health or lack thereof of your application pods. Liveness probes are used to know that the pod is running and alive. And if it fails, then the container will restart according to the restart policy that you have configured. Readiness probes are used to know that container applications are ready to receive traffic. And if that fails, then Kubernetes will exclude it from the service pool and make sure that traffic does not get directed to it. The two probes are configured very similarly. You can use a command such as a bash command, an HTTP endpoint, or a TCP socket, and define how these are updated according to what makes sense in your application. And here's an example of a liveness probe config for the agent in one of our staging clusters. Here we use an HTTP endpoint that gets updated every 500 milliseconds. We have an initial delay of 20 seconds that gives the pod a chance to warm up. And there are a number of components in the agent that are registered to this endpoint, such as dogstatsd, the auto discovery listeners, and the tagger. And so if any of these fail, the HTTP endpoint will return a 500, causing the agent pod to restart. And this is an example of a readiness probe configuration. As you can see, it's very similar to what we have set up for the liveness probe. And in our case, all the same components that are monitored by the liveness probe are also monitored by the readiness probe. However, the Datadog agent forwarder is only monitored by the readiness probe. The forwarder's main function is to send the collected data to Datadog servers. And in order to do this, the forwarder has to establish a connection to the servers, and as well as validate the API key that's submitted along with the data. And so if the connection cannot be established, or if the API key validation fails, restarting the pod won't actually help the situation. So that's why it's not needed on the liveness probe. But of course, we do want to draw attention to the issue that the data is not getting submitted properly.
Great. And we can see here it's a little bit of meta monitoring. Obviously, the agents, these are the liveness and readiness probes of the agent themselves that we use to gather information about the Kubernetes cluster, but obviously at the same time, we need to make sure that they are healthy. So a little bit chicken and egg situation here. Nice. So the next best practice that we want to talk about is tagging. So obviously, the number of containers that are running on a Kubernetes cluster can go up very quickly as you scale. And so the endpoints, the data points that you get into your monitoring platform like Datadog is only going to get bigger and bigger. So organizing all this data and be able to correlate that data together, it's super important. And we think that tagging is a key thing to take into account. Celine, do you want to give us some tips? So first of all, how do you, for example, add tag to those data points?
Yeah, sure. So in Kubernetes, there's a few different ways to get tags. We actually collect several automatically via the metadata that's available, such as your image tags, your pod name, your cluster name, and namespace. And it's also pretty easy to set up additional custom tags. You can actually set up specific Kubernetes labels to be submitted as tags, as well both on the pod and on the node. And you can also set up certain pod annotations to be submitted as tags. And there's also the classic DD tags environmental variable, where you can just manually define a key value pair, and that will directly update your Datadog agent configuration and associate that with all the data submitted.
Nice. So once we are able to collect all those tags and make sure that all our data, our logs, our metrics, our traces, any data has some tags. But in terms of best practices of what tags to apply, one of the things that we always recommend is to use something we call unified tagging. What is unified tagging?
Yeah, so as you mentioned, as the volume of data gets bigger, I think tagging becomes more and more important in being able to compartmentalize what you're seeing. And unified tagging allows you to easily go across the platform for a specific end, service, and version. So for example, if you see a trace error, you can quickly visualize latency in a dashboard, and at the same time visualize what the stack trace of that error is in your logs. And it's very seamless to go from one product to another with the same use of these same tags in a consistent way. And in addition, often deployments are a very sensitive time for teams to be able to monitor the health of their infrastructure. And so you can take advantage of these tags and making sure that the precise version that you're deploying is behaving in a way that is good or not. If you want to be able to dig in further what the issue is, then you can use that tag to narrow down on the scope across the product. And our docs have more detailed information about how to set up unified tagging in Kubernetes using labels. In addition to those 3 unified tagging tag keys, we also recommend using a team tag because it's really useful to be able to track ownership of the data that's reporting and knowing who you can reach out to if an issue is noticed. In addition, you can use this team tag to monitor team-based activity. And this is an example of a monitor that you can set up that uses both the team and the end tags to track anomalies in the number of pods that are running, which maybe could be a rough proxy for resources used across the cluster.
Great. Nice. So let's switch topics to autoscaling, and Charlie gave us a little bit of a teaser when he was talking about the cluster agent and how the cluster agent was implementing the external metric server spec. So Charlie, can you go a little bit deeper on autoscaling?
Yeah, well, so really there are different types of data and really core signals that one should care about. But with regards to the resources themselves, I think what we should first talk about is the HPA, the horizontal pod autoscaler. This resource was first introduced with CPU in 1.2, and then custom metrics in 1.6, and then external metrics provider in 1.10, Kubernetes. So it's been a while that Kubernetes has made available a process that enables the users to scale up and down their resources using an external provider. Now, what I'd like to talk about are the 4 golden signals. If you've read book of knowledge from SRE. There are core signals that matter when you want to know what you should do with regards to the number of replicas for a certain deployment. However, I personally believe that a critical part of the autoscaling is the workload itself. So let's start by talking about that that aspect of autoscaling in the workload itself. So you need to make sure that you have a feedback loop of scaling based on a signal, and you need to make sure the signal is correct. So as an example, if you scale a service that has a bug, and in this case, the error rate, if you scale on the error rate, you will end up with more replicas, and you will end up with more errors. So it's a weird infinite loop of scaling up and up and up, and that's the last thing you want to have. But you also need to care about the meta aspect of the signal. In that sense, do you want to have the sum of all the values over 5 minutes, or do you want the maximum, or do you want to aggregate over all the pods or all the load balancers in a region? Internally, most teams that are using CPU metrics for the saturation of their application rely on what's exposed by the kubelet, collected by the Datadog agent, sent to our servers, and then they can make sure that they can leverage all of the magic of creating functions from the backend and use the values in the HPA. And so for those of you who are not familiar with the type of metrics that we can use, long story short, we have, as I said, the CPU from the metric server to scale up and down the target. But then you can also implement the external metrics provider yourself. What this means really is a few functions in your app that respond to a call from the API server on routes. I think I know it by heart, but I don't want to make mistakes here. Essentially, APIs v1 beta1 external metrics kls.io/namespace/metric name. And so what we did is we introduced this feature in the cluster agent about 2 years ago, and we're leveraging informers that I introduced a little earlier on HPAs. And what happens is, as you create an HPA, the cluster agent will extract the metric and the labels that you want to use and fetch the metric from Datadog and expose it to the controller. Values are updated regularly, and they're only exposed if they're valid, which is a really important aspect of it. What is a valid value? And that is in your hand to decide. You have the options to. So in this example here, we are using a metric that's giving the 99th percentile of a request for a Ruby service, I'm pretty sure. And it's scoped over a service named store frontend. If the values goes over or under 2, then the HPA controller will scale proportionally. There is an important aspect in every word here. It is the average value. What happens here is the controller will take into account the state of all the replicas in the target. And if they're ready, then they will be accounted for. And it will divide the value gotten from the external metrics provider by the number of replicas, because it's average value instead of just target value. There are a few gotchas that I would want to talk about today, though. The first one is the workload itself, of course. When I advise teams on how they should set up their pod level autoscalers, I like to ask what would happen if they lose 10 replicas right now. It is critical to have a conversation around what it means to add or remove replicas. Think about the life cycle. Are you relying on disks? How is your app going to react if you add a new replicas in terms of network side effects? Maybe there is some DNS resources that will be consumed in a certain way. And so you have to know that. How much compute leeway do you have? If you had 10 replicas, but no nodes are available, you're going to have to wait for machines to boot, maybe the cluster autoscaler to instruct a scale up of the machines. So that's going to be minutes. And the leeway aspect is very important from a cost perspective, because if you have too much leeway, it's going to be overly expensive and you might not need it. But having warm machines can save you minutes, which means a lot of money sometimes. And the last thing I want to bring up is monitoring. You need to monitor the metric you're using to trigger scaling events. You need to monitor the number of replicas of the target and the underlying nodes in their life cycles. You need to know if a scale-up event is supposed to occur or not. And you need to revisit values often to make sure they're still relevant. That's something we rarely talk about, but make sure that what you're using from last year still works.
Yeah, I think you mentioned something super important, which is working with the development teams to make sure that they understand how these things works, the constraint that it has, make sure that they understand that this is not just magic that is going to save them all the time, that they really need to understand how these things works. So similar to daemon set versus extended daemon set on the things that we use internally, we also, instead of the HPA, use something called the WPA. What's that, Charlie?
Right. So the WPA controller is a custom controller that we've been using for the past 18 months or so internally. And we use it to autoscale hundreds of applications with multiple production environments. And the reason why we created it initially is because the single threshold logic from the HPA controller wasn't enough. We would end up very often in a sawtooth pattern where we would scale up, we would be above the threshold, we'll scale down, scale up, scale down. And we really wanted a buffer, not just a threshold. What's available in the HPA is a threshold available at the controller level. So it's the same for everyone, which didn't cut it for us. So basically we added that, and we've been talking with the community to get it upstreamed if possible, so people can leverage it. Now, there are two features that we introduced in the WPA that now are in upstream in 1.18, I believe. Those are features that allow to control the aftermath of triggering a scaling decision. So the metric is outside of the bounds, okay, but how much do we want to scale given restrictions on velocity? For instance, we might not want to add more than 30% of the current replicas, or maybe we're scaling a target that doesn't do well with scaling up and down within 5 minutes. It needs to boot up, maybe it's a JVM. And so you can set up windows that will prevent scaling events in that sense. And that's been working extremely well for us, and we're hoping to get that available for more people.
Great. So the WPA controller is also open source?
It absolutely, yeah. It's the same as the extended daemon set.
Perfect. So yeah, same thing. We will be adding those links once we upload the video, in case people want to give it a try. Cool. That's what we have talking about monitoring. But we wanted to take the opportunity that tomorrow KubeCon starts, KubeCon North America. But of course, KubeCon North America is online. So even if you are elsewhere in the world, you don't have to travel. You can attend. And we are attending, and we are super excited. And one of the things that it's a little bit daunting with people who goes to KubeCon for the first time is that there are so much content. It's very difficult. So we wanted to give our personal favorites, so to things that we really want to see during this week. So I'll start with my recommendations. So the first one is a session happening on Wednesday about a static analysis of Kubernetes manifest. And I think this is very interesting for me, because obviously monitoring can do a lot and can save you from problems once they reach production. But I believe that many of the errors that then cause an issue in production probably can be caught before they reach in production by making sure that our manifests are secure, are correct, etc. So I'm very interested in this session and learning more about this. And my second recommendation is a panel happening on Friday about OS in the era of Kubernetes. So is the OS still matters or not? So there are going to be several people from OS vendors. So I think it's going to be very interesting to see whether running different Linuxes in your Kubernetes VMs is still important or not. Cool. Celine, what are your recommendations for this fantastic week?
Yeah, so the two talks I thought would be interesting are on Thursday, How the Killer Deleted My Namespace and Other Kubernetes Tales by Laurent from Datadog. And on Friday, In Search of a kubectl blame command. I chose these two because I like a good story, and I thought it would be interesting to learn about what limitations they faced in trying to perform their tasks. And hopefully, we can all learn from their experiences.
Yeah, yes, the one from Laurent is the issues that we have had in the past with our own Kubernetes clusters. So this is going to be interesting and fun. Cool, Charlie, what are yours?
On my end, I'm very interested in very low-level stuff, and the rootless container has been in my radar for a while. So I'm really interested in understanding what they've found out, but at a almost theoretical level. And if there are some concrete examples as well, I feel like this is a direction where the industry is going to go. I'm seeing many people ask, what about the user ID that we're using? Can we use a certain one? Can we not use root? Can we use root? And so I want to see more about that. And the other one is on Thursday. It's the writing the kubelet in Rust. I've been following the Rust community for some time now, and I'm really interested in seeing what the kubelet in Rust would look like, especially the performance of the binary. Would it be better? Would it be faster? And what kind of bottleneck they've hit, and because you have to go very low level if you want to go very high scale.
Nice. Thanks for those recommendations. So several things before we finish. We plan to do a blog post after KubeCon with a little bit of summary of what we saw there, some of the trends that we saw on KubeCon. So if you were not able to attend KubeCon, please next week come to our blog. Because we will be publishing those summary. Also, if you want to reach out, there is a careers page if you think that the things that we are working on are interesting. So feel free to have a look to the openings that we have there. Nice. So we have time for Q&A. Feel free to use the Q&A button on Zoom. I saw that some of you are using the chat window. We can do better if you use the Q&A. We will obviously see the chat window as well, but we will start with the Q&A, and also it will allow us to answer you offline if needed. So the first question would be about the cluster agents. So you said that as your cluster grows, you need to add the cluster agent. How many? Because we know that the node agent is more or less a daemon set, but what about the cluster agent? How many replicas do we need? Celine, do you want to take that one?
Actually, this is something Charlie might know better than I do. I'll pass it off to him.
Of course. So we always recommend a high availability setup where you have at least one or three, not one, but you have three replicas, 2 or 3 replicas, and because we're using a pattern from Kubernetes itself to elect a leader using a config map. it will be very quick. It will take 30 seconds end to end for a new leader to be elected. With regards to the consumption, the cluster agent will grow in footprint as you add more services, as you add more custom metrics. There is one aspect actually that I wanted to talk about. Because we store data for the HPAs or the WPAs, the more things you add for us to query Datadog, then the more we have to store and serve. There is something to note. A new feature that we introduced at Dash is the Orchestrator Explorer. And when you use a cluster agent for that, the more resources overall you have, the bigger the cluster agent. But we're using some smart patterns in order to distribute the load so that the leader does a little more than the others, but not everything. So if a leader fails over, then the follower doesn't have to catch up by a lot. And so that's what we care about, is some sort of consistency in the election and make it as small as possible. But so yeah, internally we use 3, and we have thousands of nodes.
Good. So this one is very interesting. Are there any plans to manage monitors, like any other Datadog objects, like monitors via CRDs or operators, so you can control them at your Kubernetes object level?
Yeah, this is a timely question. Actually, we recently started development of a new CRD called Datadog Monitor that will allow you to control your Datadog monitors from kubectl. So that's something exciting, and we don't have a timeline yet of when that will be available, but it's actively being worked on.
Cool, great. So I would like to hear about Datadog for OpenShift. Do you have a specific relevant documentation on how to set it up for OpenShift end to end?
So actually, yeah. I think our doc for the OpenShift integration is pretty good, but we wanted to go really beyond, and we registered the Datadog operator that Celine talked about earlier in the Red Hat store. So it will be the easiest it can be. You just launch the operator, and it will take care of deploying the agent correctly with the SCC and other features of OpenShift specifically, and you will get everything end-to-end in just one installation. So this is something we've been caring a lot about, and with the operator, it's become even easier than ever.
Nice. So next question, I'm curious, has Datadog considered or do they use any managed Kubernetes control planes like EKS, Key, or AKS? If not, are you able to name your top locker? So I can answer that one because I was with Laurent on the Datadog on Kubernetes. So the team who actually runs Kubernetes clusters is a different team, the compute team. And we did a session on how we build our clusters. So if you go to datadogon.datadoghq.com, you can see all the episodes there. And we did one with Laurent specifically about how we build our clusters and why we made some of the decisions, for example, this one, like not using. So I really recommend to see that one because it's going to give you end-to-end visibility on how we build our clusters. And Jeremy has put the link on the chat window, so thanks for that. So last question that we have so far, how can I set the right request and limits for the node agent?
Actually, I'd love to answer this one. So this is a very, very cool one and very critical question. Personally, I've been relying on the Orchestrator Explorer a ton, and by a ton, I mean all the time, to see if some of my node groups are, and node groups is a MIG in a managed instance group in GCP or a ASG, a auto-scaling group in AWS, or I don't really know the one in Azure, unfortunately. But anyways, if one of my node groups is showing an outlier of usage for the request for the request and limits, what we do is we use an extended daemon set setting, which basically allows us to have a set of agents that is beefed up or not, if that's what you want. But essentially monitor with kubestate metrics, you can have the data on what are the requests of every deployment, the limits of every deployment, and then you can use the metrics from the agents, the kubelet ones, to see the CPU usage, to see more in details. You can go in the runtime with Docker, containerd, etc., and see more insight into actual CPU usage, the number of cycles, the throttling, etc. And with those, you can see if you're within your bounds. One quick thing I want to mention is it also depends on how much the orchestrator has been configured, and especially the kubelet and the container runtime. You can deactivate throttling, so sometimes putting limits is not that important. So you should be aware of the configuration of the kubelet as well. It's on the node in a file. I don't remember the path, but anyways. And so you can see if request and limits are actually respected. It's something that could bite you if you don't check it.
Good. So that was the last question. Again, if you have any follow-up questions or other topics that you want us to cover in this series, please reach out to us. We will be happy to answer those offline, or if you have any other topics that we want to cover in this series. So thanks everybody for attending. I hope you got some ideas on how to better monitor your own Kubernetes clusters, and have a great KubeCon.